Assalamualaikum and selamat sejahtera. Today we are going to learn the fourth subtopic of chemical bonding, which is intermolecular forces. Hopefully, at the end of this lesson, you should be able to describe two types of intermolecular forces. The first one is van der Waals forces that consist of dipole-dipole interactions or permanent dipole, and London forces are also known as dispersion forces. And the second type of intermolecular forces that you are going to learn today is hydrogen bonding. What is intermolecular forces? Intermolecular forces are the attractive forces that exist between molecules. This diagram shows two hydrogen chloride molecules. Hydrogen chloride molecules is a covalent compound, and there is a covalent bond formed between hydrogen and chlorine atom. So, there is a force exists between these two molecules that keep the molecules attracted and closer to each other. We are going to study what is the type of intermolecular forces that exist between these molecules and the other covalent molecules as well. If we compare the strength of the covalent bond and intermolecular forces, the intermolecular forces are very much weaker than covalent bond or ionic bond. Since intermolecular forces is weaker than covalent bond, so it is easier to separate these molecules compared to break the covalent bond between atoms in the molecule. The strength of intermolecular forces are responsible for the physical properties of simple molecular substances such as melting and boiling point. Therefore, different molecules will have different types of intermolecular forces that will affect the value of melting point or boiling point. For example, water molecules has a boiling point of 100 degrees C, while an alkane or hydrocarbon boils at a much lower temperature than water molecule. Why do this happen? Because water molecules and an alkene or hydrocarbon has different type of intermolecular forces. We are going to study the two types of intermolecular forces, which is van der Waals forces and hydrogen bonding. There are two types of van der Waals forces. First is dipole-dipole forces, and the second one is London forces or dispersion forces. So in general, the intermolecular forces increase in strength according to the following sequence. London forces is weaker than dipole-dipole forces, and dipole-dipole forces is weaker than hydrogen bonding. Let's take a look at the first type of van der Waals forces, which is dipole-dipole forces. Dipole-dipole forces is the attractive forces that exist between neutral polar molecules. As you have learned in subtopic 4.2, polar molecule is a molecule with uneven distribution of electron, meaning that a polar molecule have two distinctive charges at each end of the molecule due to the difference in electronegativity between bonded atoms that made up the molecule. For example, hydrogen chloride molecule is a polar molecule. Chlorine is more electronegative than hydrogen. Therefore, we have hydrogen with partial positive charge at one end and chlorine with partial negative charge on the other end of the molecule. We all know positive charge attracted to the negative charge, isn't it? Therefore, dipole-dipole forces is the forces arise from the attraction between partial positive charge on one molecule and partial negative charge on the other molecule. The second example is showing the dipole-dipole forces that exist between hydrogen sulfide molecules. Just like hydrogen chloride molecules, hydrogen sulfide has hydrogen with partial positive charge and sulfur with partial negative charge because sulfur is more electronegative than hydrogen. Therefore, partial positive charge of hydrogen on one hydrogen sulfide molecule will attracted to the partial negative charge of sulfur on the other molecules, forming a dipole-dipole forces. So, as a conclusion, please remember this. Dipole-dipole forces arise between polar molecules when partial positive charge on one molecule is attracted to partial negative charge on the other polar molecule. Before we move on to the second type of van der Waals forces, I would like to ask you, if dipole-dipole forces exist between polar molecules, is there any intermolecular forces exist between nonpolar molecules? Nonpolar molecules has even distribution of electron, therefore there is no partial positive or partial negative end in nonpolar molecules. So, can nonpolar molecules attracted to each other? To answer this, let's learn about London forces or dispersion forces, which is the second type of van der Waals forces.